also about the how to calculate average value and RMS values for another different waveform shapes. That is the waveforms which will be asked in previous examinations. For example, here consider the waveform which is given in previous final examinations. There is voltage waveform here. Like this, the waveform is given. The maximum value is, for example, 4. The time period is 2, 4, 6, 8, like that here. Okay, here this is very most important model. That is, this waveform consists of straight line like a triangular and square. That is combination of sawtooth and square waveform. Okay. Then before going to calculation of RMS and average values, you must find out what is the time period for the given waveform. Let us find out first of all time period T. Okay. From the waveform, observe here what is the time period value here. That is exactly 4 here. Why? Because after 4, same the previous waveform will be repeated again. That's why where the waveform will be repeated at the instant, we can call as the time period. Then again we can find out what is the equation of the waveform. Okay, the given waveform is voltage here. First of all, the first waveform will be starting is a straight line here. The waveform will be starting straight line. After that, it is a square waveform. Then first of all, you can find out the equation of the straight line. Then before that, you can find out what are the points of the straight line here. Okay, this is origin 0, 0, and this is x-axis 2 and y-axis 4 here. Then from 0 to time period, the line is straight line. Then you have to find out equation of the straight line here. That is, you know formula y minus y1. Y1 is, this is x1 and this is y1 by x1 y1 and this is x2 y2 here. You know the formula y minus y1. Y is the y-axis variable is voltage V equal to y2 minus y1 4 minus 0 by x2 minus x1 2 minus 0 into x minus x1. X is x-axis variable t minus x1 0. Then that is V equal to 4 by 2, that is 2 into t, when the time less than from 0 to t less than 2, and also when the time period is 2 less than t less than 4. Why? Because you can find out the equation up to 4. What is the reason? Our time period is 4. That's why up to time period 4, you can find out what is the equation of the waveform. Okay, from 2 to 4, observe 2 to 4, it is a square waveform. In the problem, the negative value, that is the square waveform value is minus 1, consider minus 1. That's why V equal to minus 1 for 2, 2 less than 3 less than 4. In the same period, the value of voltage is square, it is constant. What is the value here? Minus 1. Okay, these are the definitions of equations for the given waveform. After finding equations, then you can find out average value. That is V average. What is the formula here? 1 by t, 0 to t, then V of t dt, V dt. And the waveform having two definitions, 1 by 4, t is 4. From 0 to t, 0 to 2, what is the value here? 2 into t dt, plus again from 2 to 4, what is the value here? Minus 1. that is into dt. This is the function definition. Then after that, you can apply integration on both sides here. Integration for two functions, that is 1 by 4 and 2 is constant. What is the integration of t? That is t square by 2. Integration of t is nothing but t square by 2. Apply the limits 0 to 2. Here minus constant minus 1 right to the outside. For constant, what is the integration for constant? That is t 2 to 4. Okay, na? Why we are writing t here? The differential variable is in terms of dt. That's why we are writing dt here, t here. If the differentiation is with respect to dx, then we have to write down x here. Then 2 will be cancelled. 1 by 4. Apply the limits here. 2 square 4 minus 4 minus 2. 4 minus 2 2. Again 4 minus 2 2. That is 1 by 4 into 2. Nothing but 1 by 2. Okay, for this waveform, the average value is 0.5 volts. Okay, after finding average value like this, then we have to find out again RMS value. That is VRMS. We know the formula 1 by T 0 to T function square V square into dt. For the whole function square root. Don't forget to write the square root, okay, to every step. Again, what is function here? 0 to 2, that is 2 into t per square 4t square into dt plus from 2 to 4 minus 1 whole square, nothing but plus 1 into dt. Then here this is whole function. Then 1 by 4, 4 is constant. Then for t square, what is the integration? To t cube by cube, t power n plus 1 by n plus 1. Then apply the limits 0 to 2 plus minus 1 is constant. For constant integration is t. The limits are 2 to 4. Then square root 1 by 4. Then apply the limits here. 4 by 3 is constant. 2 power cube, that is 8 minus 0 plus 4 minus 2. This is one function. Then 1 by 4, 4 into 8 by 3 plus 2. Then multiply with 4. Then 8 by 3 plus 1 by 2. That is square root. We have to simplify the equation here. 2.66 plus 0.5 square root, that is 3.16 square root. Okay, volts. So this is the RMS value for the given waveform here. So like this, for every waveform given in the examination, you first of all you can understand it is a straight line or square or sine wave. Every waveform having only three combinations. Either it is a sine or it is a straight line like triangle or square waveform. Combination of two or three waveforms also are given. Okay, clearly you can understand. Okay, what is the straight line and where is the square waveform and where is the sine waveform given. After that, find out the time period of the given waveform. Then find out what is the equations of the waveform up to the time period. Then find out by using formulas, average values and RMS values for the given waveforms. And like that also, you can take another important problem which is also given in previous examinations. Consider the waveform shape here, that is triangle. Consider it is a voltage and it is T. The maximum voltage given 10, the time period 2, 4, like that here. Okay. Then this is a given waveform. For this waveform, we also find out what is the average value and as well as what is the RMS value. Okay. Before that, what is our first step here? You have to find out what is the time period of the waveform. That is t equal to 2. Why? Because after 2, the same waveform will be repeated again. That's why the time period of the waveform is 2. Okay. Here it is triangle. Then we have the two straight lines. That is one straight line is going to upper side. What are the limits here? 0, 0 origin. And at this point, what are the points here? This is the middle. For middle, what is the time period? 1 year. That's why what are the points here? 1, comma 10. Okay, this is the one straight line. What is another straight line? That is downfalls. Okay, for downfalls. Then here what is here? Point 1, 10. And here 2, 0. No y-axis value here. Okay. For upper side, that is going increasing order, the points are x1, y1, x2, y2. Okay. For downfalls, the points are x1, y1, x2, y2 here. So like this, you can take the points to find out the straight line equations of the triangular shape. So one shape is increasing order, one straight line, and another straight line is downfall side. So for downfall, the first point is the upper and down point in the second point. That is x1, y1 upper side and x2, y2 lower side. So for in an upper side straight line and downfall taken as x1, y1 and upper side taken as x2, y2. Like that, you can find out straight lines here. Then for first equation from 0 to 1, okay, that is from 0 to 1, that is the line is in the upward side, so going to the upward. Then what is here? V y minus y1. Y means V minus y1 0, y2 minus y1 10 minus 0, x2 minus x1 1 minus 0, x is t minus x minus x1, x1 is 0. Further, v equal to 10 into t when 0 less than t less than 1 for this time period. Similarly, for downfall straight line, that is from not 0, that is from 1 to 2. Okay, from 1 to 2, the line is downfall. What is x1, y1 value? 1 minus 1, comma 10. That's why y minus y1, v minus 10. y2 minus y1, 0 minus 10, 5. x2 minus x1, 2 minus 1. Then x minus x1. x1 is 1 here. That's why t minus 1. Then simplify equation here, v minus 10 minus 10 by 2. That is minus 10 by 2 minus 1. That is minus 10 t minus 1. Simplify the equation. That is v equal to 10 minus 10t minus 2 minus plus 10. That is 20 minus 10 into t. So this is the equation of the function when 1 less than t less than 2 here. Like that, we have to find out the function equations also for the given waveform. Then after finding the waveform, what second step? You have to find out average value. Therefore, average value, that is V average equal to what is time period 2? 1 by 2 integral 0 to 2 function V into dt. Okay, here the time period is 2. Okay, here the function V having two limits, that is 0 to 1. What is the function value? 10 into t plus again from 1 to 2. What is function value? 20 minus 10 into t dt. Okay. Then you can apply integral, that is 1 by 2, 10 is constant, for t integration is t square by 2, t power n plus 1 by n plus 1, limits are 0 to 1 plus for 20 constant integration t minus 10 for t square, the integration is t square by 2. Then the limits are 1 to 2. Then 1 by 2, apply the limits here. 10 is constant, 10 by 2, 1 minus 0 plus 20 into 2 minus 1. Apply limit after applying limits. Then 10 by 2. 2 is constant. 2 square. 4 minus 1 square. 1. Then simplify the equation. 1 by 2. 10 by 2. 5 plus 2 minus 1. 1. That is 20. Minus 10 by 2. 5. 4 minus 1. 3. 5 into 3. 15. 20 minus 15, 5. 5 plus 5, 10. 10 by 2, 5. That is 5 volts. So this is the average value for the given waveform, 5 volts. Similarly, for the same waveform, we have to find out RMS values also. It is compulsory problem in university examinations also. Finding of average value and RMS values for the given waveforms. Any waveform is given in examinations. Then what is formula here? 1 by t integral 0 to t function square v square dt, then square root. Again, we know the voltage value having two combinations, two limits, that is 1 by t 0 to 1 10 t whole square dt plus 1 to 2 20 minus 10 into t whole square. So that is function square whole square. Then into dt. For the whole function, write down the square root also. Then whole square root 1 by 2, 10 into 10, 100 For t square, limits are apply integration t cube by 3. The limits are 0 to 1 plus 20 10 minus t whole square. Then apply the a minus b whole square. That is a square. Okay. First of all, extend equation here. A square minus b square 2 into ab. Then 1 by 2 is there for the whole function multiplication. Then square root here 1 by 2. Apply limits here 100 by 3 is constant. 1 cube minus 0 that is 1. Okay, plus here 400 is constant. For constant the limits is t, integration is t. Then apply the limits 1 to 2 minus 100 for t square integration is t cube by 3. The limits are 1 to 2 plus 400 for t. The integration is t square by 2. The limits are 1 to 2. Okay, this is for whole function. Then simplify the equation. 1 by 2, 100 by 3, 400 into 2 minus 1, 1. That's why 400 minus again 100 by 3, 8 2 cube minus 1 cube, that is 8. Then into 8 plus 400 by 2 t square 2 square, that is 4 minus 1, that is into 3. Okay. Apply after applying limit. The t square nothing but 2 square minus 1 square. So therefore minus 1 3. Then here you can simplify the equation 100 by 3 plus 400 minus 800 by 3 plus 600 for whole square root. The 1 by 2 going to the enter can eliminate 1 by 2 also. That is eliminate the bracket. That means 50 by 3 plus 200 minus 400 by 3 plus 300 whole square root. That is 50 minus 400, 500 minus 350 by 3, 1500 minus 350. That is 1150 by 3. Okay, after simplification. So this is the RMS value for the given waveform shape here. Okay, like that, for any given waveform, you must find out average value, RMS value. First of all, you can find out the what is the time period in the given waveform. After that, if the waveform is straight line, you can observe it is straight line or it is a square or it is a side waveform. Then find out the equations of the given waveform. After that, by using the formulas, you can find out average value and RMS value. The integration, apply the limit, then you will get the value here. Please subscribe our channel and share to your friends.